Hello everyone and welcome to the tutorial on how to create a pawn, how to create a controller, and using the enhanced input. So let's get it all started. So how do you create a C++ again? It's either you go to the C++ classes and to the folder of your project, then right click, new C++ class. The other way to do this is through tools, new C++ class. Right, so for now, I'll create a pawn. I'll call this test pawn. And here's our test pawn. So there's a .h for the header file and the CPP file. So for our pawn, I will create a sphere as its static mesh that is with a spring arm connected to it and a camera component connected to the spring arm. Then for movement, I will use a floating pawn movement. So first we do a classic or static mesh. So we call that U static mesh component. Static mesh. So how do I know about this class and the name of it? So that is why you need to know how to use the blueprint first before C++, because you have to know what kind of components you need. So if I search here static mesh component, you'll see this is static mesh component right here with the name of the class U static mesh component. Okay, so there's a static mesh. Then I want my spring arm component, new spring arm component, spring arm. I also want my camera component, new camera component, cam component. Then finally the floating pawn movement, new floating pawn movement, uh, floating pawn. Alright. So let me just restart my Visual Studio so it will appear. And there we go. It should appear now. So for all of these, I will use a U property to show how to show in the editor. Then for my specifier, it will be visible anywhere. And I'll use this for all four components. Now, how do we create those components? So in our constructor, this one, our constructor, this is where we create the components. So for static mesh, I have static mesh is equal to create default sub object. Then the open and close less than greater than. This is where we put the class type. In this case, it is U static mesh component. And finally, the open close parenthesis, this is where we place the name of the component. So I'll put it static mesh. So you can name it anything you want. I'll also do this for the other components. Spring arm, so you go to create default sub object, U spring arm component, spring arm. Also for my camera, cam component, is equal to create default sub object, U camera component, camera component. And finally, my floating pawn, create default sub object, U floating pawn movement, floating pawn. There. Now a good practice is when you create the components, you include appear the header files of it. Now, how do we find it? For, let's say, static mesh component, I know it's called static mesh component, not H. And you'll find out it's under the components folder. So, we do that by include components static mesh component.h. And we will also do this for the spring arm. For the spring arm, it is under game framework. Include game framework. Spring arm component. And for our camera, it's under camera. Camera component.h. And finally, our floating pawn movement. .h. And here we have, it's under game framework as well. Include game framework. Floating pawn movement.h. There. So it's a good practice to always include. Next, what another practice that you should be doing is to set the root component. So usually the actors have a root component already that you include well in the blueprint, right? So just to see, when you create an actor, by default they have a scene component. Default scene root is a scene component by default, but when you create a C++, it doesn't have. What it will do is the very first object component you created will be the root component, and sometimes it's kind of doesn't work, and it kind of messes up with your game. So what you do, you manually set root component. So this is a function of this is a method of actor which will set the root component. And here I'll use static mesh, and I'll be doing this for that. Next, spring arm, I want it to attach to the static mesh. So I type here spring arm arrow, because it's a pointer, set up attachment. And for here, the parent would be static mesh. Then the camera component, I want it attached to the spring arm. So set up attachment spring arm. The floating pawn movement, you don't have to attach it to anything. It will just hang in there. And if I want to change, let's say the default values of like spring arm, so like spring arm, I want the default value of the target offset, which would be a f vector. So I'll type here f vector 0, 0, 50. Okay, so what did you do? We added the components that we needed: static mesh, spring arm, camera component, and the floating pawn movement. Then in the CPP file, this is where we create the actual components. Create default sub-object, the name of the class, and then whatever name you want it to be. Then we did it for all the components. Then if you want to set the root component, you type set root component, and then whatever component would be that you specify here will be the root component. Then if you want to attach things together, you call the component arrow setup attachment. Then whatever is inside will be the parent. So let us go and compile. And there you have it, compile complete. So let us create that blueprint of that C++ class. So I'll just create a folder here, test. So for here, blueprint class, then we go to all classes. Here we'll list down all the classes. We type in our test pawn, and there it is. I'll call this BP test pawn. If you open it, here we have the static mesh as the root component. The spring arm connected to the static mesh, and the camera component connected to the spring arm. And it looks like this. So for static mesh, I will set the mesh to be the material sphere, and also change the material. There. Floating pawn, I can change it later on, but there we have it. Here's our pawn, ready to be used. Now, here comes the harder part, which is the controller. So before we go to controller, let us review again how the input system, the new input system works. So in here, I'll create an input. So whatever action you plan to do, like input action, we create one by right-clicking, input action. This will show this will be whatever whatever action the player will do. So for move forward, if I enter it, it will show all of these. What's important is this value type. So the value type, I will make it as axis 1D because I only want it to move forward and backward. I also want to create for moving sideways. So move right. So in here again, what is important here is this value type. Then for the input mapping context, this one tells you what key to press for the input action. So in here, I'll just call this test context. So here we have the mappings. For the mappings, for move forward, it will be W, which has no modifier. But with S, which would mean backward, the modifier would be negate, or the opposite, the invert. So same thing with the move right. We have a D to move to the right. Then we have also A to move to the left, which is negate. Okay? Now that we have those, let us go and create our C++ class. In here, I will choose player controller. This will be my test player controller. Compile complete, and let us go reload. So test controller is a bit different. You will notice that it is almost completely empty. So what do we need for test controller? I want a begin play that is in the protected virtual void begin play override. I also want my what else do we need? Okay, another thing that we need is virtual void set up input component. So this one is a function of the controller. This is where we bind the keys. One thing that we need, I'll include right here, would be input action value.h. this one, I need this for our movement. So what we have is we create a function void move forward, and in here we use the input action f input, hold on, input action value, right, f input action value, and then ampersand value. Now we need to do this also for our move right. Move right. Okay, so this value is whatever value will pop up. So this could be boolean, this could be a float, this could be a vector. So it really depends on whatever we set right here. This one's, it's whatever value type. So we're gonna have to cast it later. So move forward, move right. Okay. Another thing that we need would be the input actions that we created. So class u input action. This would be move forward action, and also class u input action move right action. We also need a context here. Class u, let me just find a mapping context u input mapping context, and call this mapping context. For all this G, it will be u property, and instead of visible anywhere, it will be edit anywhere. Unlike the other components we had, these ones need to be edit anywhere. We need to edit it. All right, so let's create the definitions. We simply just hover, and then the screwdriver will automatically create the definition. So we have that. We have this. Our move forward. And our move right. Alright, so important. If it is an override, you must call the base function. In order to do that, we call super, and then begin play. Same thing with our setup input, super, setup input component. So I think our setup, I think it's called set input. Hold on. Let me just double check. For the setup input component, it is actually under a player controller setup input component. All right, so let me just test this out first. I will compile. Okay. So let me just double check again. Setup input. Okay. For move forward, what we do is you try to make it forward, so float the value of whatever will pop up is equal to the value dot get the float. And for move forward, it is get pawn. So I get the pawn so I can access the add input, add movement input, right? For the direction, it'll always be the forward vector of the pawn. And for the force, it will be val. So same thing for the move right, except instead of the forward, we get the right vector. So what does this mean? So if I move right, I am basing it on the right vector of the pawn wherever it's facing. Then the val, this will be how much it will move to this direction, to its right. Okay. Now, now for this part, for the enhanced input component, enhanced input, you have to add the mapping context manually. So in order to do that, if, let me just include the enhanced input component, I also need to include enhanced input subsystems, right? So you local player subsystem, no, you enhanced input local player subsystem asterisk, it will be a pointer system is equal to cast. So we're casting the with the class of u enhanced input local player subsystem, and whatever's inside the parentheses is what we're trying to cast, which will be get local player. Oh no, wait, no, it is get local player get system, get subsystem with the u enhanced input local player subsystem, and inside will be the local player, which is get, oh wait, hold on, okay, it is actually u local player and then get subsystem, then inside here will be the get local player. So if it is not null, what I do is system add mapping context. And which one will be the mapping context? The one that we just added at the header file, right? We have a mapping context here. Then for priority 0. Alright. That's one down. Next, we have to actually bind those actions. So if you enhanced input system subsystem no you enhanced input component is equal to, we cast the to you enhanced input component, and which are we casting? We are casting the input component. Input component, this is a component in the controller which handles the input of the player. So we're just casting it to the new enhanced input component. So component arrow bind action. So this is where we bind the actions of the these ones into the functions. So here, bind action, I want my move forward action with the E trigger event. E is enum, remember? So enum, we have to select a certain enum. So E trigger event colon. Then you should have access to all the enums I want triggered. For class, it will be this. Then finally, for our here, the F enhance in action handler, we simply get the move forward. So ampersand a test player controller colon move forward. So again, the bind action, what it needs is the input action, whatever trigger event you want. For me, it's trigger. This is the whatever object or controller. And finally, the end will be the function or the address of the function that needs to be called, which is the move forward. So we do this also for our move right. So component bind action, move right action. E3 or enum will still be the same. Triggered this, and then a test player controller move right. Okay, so this part complicated, but you have to go through it at least once. So let us try to compile. Compile complete, and then let's test it out. For controller, I will get our test controller, test player controller here, and I call it BP test player controller. And then I will also create a game mode just so we can test it out. I'll call this test game mode. So you'll see that whatever we added a while ago, the mapping context, move forward action, move right, that's all here. So our mapping context, I will use test context. The move forward, IA move forward. The move right, IA move right. And that's it for controller. So let's test it out. I will just set the default BP test and BP test spawn. Okay. So for here, I will just change it to the game mode that I just created and play. And you'll see that I am able to move our pawn left and right. Okay. Now what if instead of the move left and right, I want in just one input action? So there's a way. So we use like IA movement. For this one, to move forward and backward, left and right, I use axis 2D vector 2D. Then the text context in here will be the movement. So for D, no modifiers. Because in general, it will always be in the x-axis. Same thing. For A, instead of none, we use negate. Now, since W and S is a different axis, we have to swizzle it. So in this case, if you check the modifier, you have swizzle input, which turns it to the y-axis. Same thing with S, and not only just we swizzle, but we also negate. Then for code, almost the same, except we have to use a different function and a different input. So this move const f input action value. And don't forget, we also need the input action for the move. There we go. So for the test controller, here let us comment this out first. And also include, we create a definition for the move, which is, instead of float, we use f vector 2d. Vector is equal to value dot get f vector 2d. So if I want to move forward, I need to get the y-axis of our vector. If I want to move right, I need to get the x-axis of our vector. There we go. Then same thing here, component, bind action, move action. The trigger event, same thing, trigger event, trigger this, and then finally the function a test player controller move. Right? So let us compile that. Okay, error. Error. Okay, let's try to read. Parsing. So it's on the 24th. Hold on. Okay. So we have bind action, move action, which is the input action. We have triggered for the trigger event, and then the move right here. So if we test it out, we play it. It's not working because we forgot to add the input action in the blueprint. And so we have the input action movement, compile, we play. Then we have the movement. Okay. So again, right now it's only using the move action. I have commented out the move forward, move right, but it still works because if you recall the context that we created, oops, sorry, that's not the context. The context that we created, it uses the 2D axis, D, A, W, and S right here. Okay. Now, if you're to create a character, the difference is you don't have to add any movement or other things unless it's needed, right? Because the character already has its own collider, it has its own movement, it has its own skeletal mesh. So if I create the character here, let's say test character. Okay. So for the test character, what I want is just to add the spring arm and the camera component. So same thing again. Hold on. There we go. So we have class, view, spring arm component, spring arm, and class, view, camera component, camera component. That's all I want to add. So same thing here, spring arm is equal to create default sub object, and use spring arm component. I'll call this spring arm. Then we also want the camera component is equal to create default sub object view camera component. I'll call it camera component. Don't forget the view property visible anywhere for both. And then for here, it really depends on where you want to set the spring arm. Okay, so let me just include here first. Include game framework spring arm component and include camera component. Okay, so again, setup attachment. So it's up to you. You can do in the root component, which is root component. You can do that. If you want to put it in the capsule collider, or you can also do it on the skeletal mesh. I think we call it, it's called skeletal. No, get mesh. So this is the skeletal mesh. It's up to you. For now, I want it in the root component, so root component. Then, of course, the camera will be on the spring arm component. Setup attachment, the spring arm. That's all. I put a default value for the spring arm. You can choose not to. Spring arm, target offset is equal to f vector 0, 0, 80. Okay, I will compile. Compile complete. Then I'll add in the test character. In this case, pp test character. So for the mesh, I will just add in the Manny. I'll just put him down here, turn here. Then we have our spring arm that is connected to the capsule, and the camera connected to the spring arm. So you'll see character movement is here, mesh is here, arrow is here. They're all there. These are all part of the character class. So compile. Let's test it out. Test game mode. Instead, I'll change it to BP. test character. Compile and play. And there we have our character moving around. You can't look around because we did not add um, that controls, but uh, you don't have to also. Anyway, for project 1. Alright, so that is the tutorial for our pawn and controller. So it is okay to copy parts of this. It is kind of how it is anyway, but try to understand it as well. Just know that this is almost the same as just doing it in Blueprint. So if you recall, I just want to show you here. If you recall the add mapping context, that is the same as doing in here the local